we are going to estimate CO2 emissions from electricity usage, part 2. We're going to jump right in. How much CO2 is produced from using a game console for 5 hours? Let's remember that when we're talking electricity, 1.37 pounds for 1 kilowatt hour. That means we are trying to find kilowatt hours. Well, if I'm talking about game console, this is how many watts. So we are starting with 50 watts. I know that there are 1,000 watts to 1 kilowatt. So anytime you start with watts, your first step is to change those watts to kilowatts. Then you ask yourself, how long am I doing this? Well, the problem says 5 hours. Once you have kilowatt hours, you multiply by the 1.37 pounds per 1 kilowatt hour. Kilowatts cancels out with kilowatts, hours cancels out with hours. We take 50 divided by 1,000 times 5 times 1.37. I don't know if that was really messy. Let's try that again. 1.37. And we end up with 0.3425 pounds of CO2. Number 2. How much CO2 is produced from ironing clothes for 1 hour a week for 4 weeks? Okay, we're ironing clothes. Sounds awful. So we need a clothes iron. It is 1,100 watts. Well, what is our first step after watts? We know that there are 1,000 watts in 1 kilowatt. Watts are gone. Now, the next is hours. 1 hour per week for 4 weeks. Well, week 1, week 2, week 3, week 4. If every one of those is an hour, that means there's 4 hours total. Then I would take that, multiply by 1.37 pounds over 1 kilowatt hour. So you have to make sure you're paying attention to the words so that you know what how many total hours, right? It's not just 1 because you're doing that for 4 weeks. So I have 1,100 divided by 1,000 times 4 times 1.37, which gives me an answer of 6.028 pounds of CO2. If someone sleeps with an electric blanket turned on for 8 hours each night during the 4 coldest months of the year, how much CO2 is produced? Okay, electric blanket. We're talking about 200 watts. All right, I know 1,000 watts is 1 kilowatt. Remember, the first step is always watts to kilowatts. Then I say, okay, hours. Oh dear, 8 hours each night, 4 coldest months. Well, I'm going to say that 1 month, we're going to approximate here, is about 30 days. So if I have 4 months, well, multiply by 4, that gives me 120 days. And each day, we're doing this for 8 hours. So times 8 hours, and that gives me 960 hours of this blanket. So 960 hours. I have kilowatt hours, so then I go to 1.37 pounds divided by 1 kilowatt hour. Kilowatts gone, hours gone. 200 divided by 1,000 times 960 times 1.37, and I end up with roughly 263.04 pounds of CO2. Again, you've got to play with that. How many hours? Use your common sense to think about hours. How much CO2 is produced from running a dishwasher for 45 minutes? All right, dishwasher. We find it. It uses 1,500 watts. 1,000 watts is 1 kilowatt. Watts are gone. How many hours? 45 minutes. Okay, so if you're like, okay, what do I do? Remember that 45 minutes is part of an hour. Well, how many minutes are in an hour? This is just kind of like a dimensional analysis problem. We know that there are 60 minutes in 1 hour. So that makes your minutes go away. And you take 45 divided by 60. and it gives you 0.75 hours. So I'm going to multiply by 0.75 hours. So you can do that anytime you're given the number of minutes. You just divide by 60. It'll tell you what portion of an hour. Then I can multiply by 1.37 kilowatt hours. Excuse me, goodness gracious, 1.37 pounds per kilowatt hour. My kilowatts cancel out, my hours cancel out, and my work is 1,500 divided by 1,000 times 0.75 times 1.37, and I end up with 1.54125 pounds of CO2. All right. What would be the CO2 savings from using a ceiling fan for 8 hours instead of a one-roomed air conditioner for 8 hours? Now you've got two different ways you can go about this. So we are comparing, let's see, a fan that's in the ceiling, which is 100 watts, and a one-room air conditioner. So if I say, okay, we're going to take AC minus the fan. So 1,100 watts minus 100 watts gives me a difference of 1,000 watts. So the savings in terms of wattage is 1,000, right? So I'm saving 1,000 watts using the fan. So I can use that and say, okay, the savings is 1,000 watts. So 1,000 watts is 1 kilowatt. So that makes my watts go away. And I'm doing this for 8 hours. So 8 hours. And then 1.37 pounds per 1 kilowatt hour. So kilowatts go away, hours go away, and I take 1,000 divided by 1,000 times 8 times 1.37, and I end up with 10.96 pounds of CO2 savings. Now, you could also do these each separate. You could find the CO2 for the fan, you could find the CO2 for the AC and subtract, and you would get the same thing of 10.96 pounds. Let's do one more. Suppose the cost for electricity is 10 cents per kilowatt hour. What is the cost for using a game console for 5 hours? Now, when you think about this, they give you we're not talking about CO2 anymore. So that 1.37 is out the window. Now we're talking about 10 cents per 1 kilowatt hour. So I still need kilowatt hours, but my final ratio changes. So we're talking about game console. We had it earlier. Where did it go? There it is. So 50 watts, just like we started with earlier. So 1,000 watts is the same as 1 kilowatt, so the watts go away. We're doing this for 5 hours. And then you would say, okay, now we're talking about 10 cents per 1 kilowatt hour. Kilowatts go away, hours go away. So we take 50 divided by 1,000 times 5 times 10 cents. And we end up, if we're talking money, we round to the nearest penny, 2 decimal places, 3 cents. It'll cost you 3 cents to run that game console for 5 hours. That's not talking about the TV. That is just the game console. But 3 cents for every 5 hours. So you can start charging your kids for playing video games is the basic idea there. All right, so really pay attention is the point of this last one. What are they asking for? You use the units and the ratios to guide your work.